Okay, so we're going to show today, using Euler's formula, that the sine of the sum of two angles, A and B, for any real angles, is just the sine of A cosine B plus the sine of B cosine A. And recall, Euler's formula says that e to the I theta is equal to cosine theta plus I sine theta, where I is the imaginary unit square root of -1, and theta is an angle. Okay, just very basic stuff to lay out. And we're going to use this to show that this formula is true. And with this formula, we're also going to show that the sine of 2 theta is just 2 sine theta cosine theta. Okay? So, we're going to start with actually plugging in theta as A plus B. E to the I A plus B, because in this case, this is really theta. This is the same thing as theta, the angle. It's just broken into a sum. And this will therefore equal cosine of A plus B plus I sine of A plus B, plugging in theta as A plus B. Okay. Now from here, there's not much we can actually do on the right-hand side, but there is something we can do to the left-hand side. Now, remember, this is the same thing as e to the I A plus I B, which is the same thing using the distributive property. And this is the same thing as e to the IA times e to the IB, because if you're, basic rules of exponents, right? X to the A times x to the b is equal to x to the a plus b. So we're using this kind of property here. With that in mind, now let's rewrite this. So remember, e to the IA, and I'm actually going to highlight this in a different color. So this we'll do in red, this we'll do in blue. So e to the IA is just cosine A plus I sine A. And e to the IB is just the same thing with b's instead of a. Okay, so this is really equal to e cosine A plus I sine A, all multiplied by cosine B plus I sine B. Now let's take this even further. So we just said that cosine of A plus B plus I sine of A plus B is really equal, because this is really e to the I A plus B, to cosine A plus I sine A times cosine B plus I sine B. And this is really just e to the IA times e to the IB. Okay, that's what we're really showing here. And all we have to do here is now simply on the right side, we're going to simplify this. So if we FOIL it out, cosine A cosine B plus cosine A I sine B plus I sine A cosine B plus I squared sine A sine B. So this is the result of the right-hand side. And recall that I squared, if I is equal to square root of -1, then I squared is equal to -1. So we can just take all of this here and duplicate it. And all we have to do is just tweak this little thing into minus. Okay. Now let's rewrite everything here. So let's rewrite it in a form that may look very interesting. So we're going to put the cosine A and cosine B minus sine A, sine B in the front, the things without the i's. So we're going to put these two here. Hopefully you guys saw that. And then from there, we're going to simply just tag on the imaginary parts. Cosine A, I sine B, plus I sine A cosine B. And we're going to take this even further. So all the same stuff. I'm just rewriting everything in the same way. And I'm simply making tweaks. And from this, we can factor out, in this little bubble, or box, notice we can factor out an I. So this is really just I times cosine A sine B plus sine A cosine B. And we just said that this is really equal to cosine of A plus B plus I sine of A plus B. Okay, now all we have to do here is just recall, okay, this blue part is the imaginary unit, and this red part is the real part. And guess what, guys? Not only do we just show this formula is true, we just also we have shown that the cosine of the sum of two angles is this. So let me show you. So this red part is the equivalent. So cosine of A plus B is equal to the cosine of A cosine of B minus the sine of A sine of B. And then with the blue part, the imaginary units, this is really saying that the I sine of A plus B is equal to I cosine A sine B plus sine A cosine B. But we can kind of cancel out the i's and just come up with the formula that we were looking for, and is the sine A cosine B plus cosine A sine B. I just rearranged these two into the form that looks nicer, and there you have it. We have just shown that the sum of two angles is the sine A cosine B plus cosine A sine B. And we also showed that this formula for cosine exists as well. So this is where you derive the two formulas used in trigonometry. And with that in mind, let's go one step further. And now we can say that the sine of 2 theta is equal to 2 sine theta cosine theta, right? What's interesting about this is that if you did this with the idea that it's really saying that the sine of theta plus theta is really what this is equivalent to, and you apply the formula, so sine theta cosine theta plus sine theta cosine theta, right? And this is really the same thing, so there you have it, 2 sine theta cosine theta. So there you guys have it. That's very nicely done there. And this is your result. So we have just shown by using Euler's formula and comparing the real and imaginary units that where the formulas are derived from. So this is a pretty cool video. I would recommend you guys take a crack at doing this proof all by yourself, or derivation, I would say. All right, well, have a good day.